Hey everyone, so today what we will be doing is we will be attempting to solve this one problem given here. So apparently this is not just about calculation, and it's not even calculation, it's about confirming the accuracy of a calculation. So let's look at the problem. Read the given statements carefully and select the correct option. So we have two statements. First statement says that the P over Q form of 15.712121212 and just like that recurring plus 4.322222 and so on recurring till infinity is 389 divided by 90. And on the other hand, the other problem says that the value of the cube root of 0.125 times the fifth root of 0.00032 to the power negative 2 divided by the fifth root of 0.00243 to the power negative 3 times 27 to the power 2/3 is equals to 3 over 80. So to confirm the accuracy of these two statements, and then we're good to go and move on to our next question. So there, each of the options says that first one says that both are true, second one says that both are false, and the third one says that the first one is true but second one is false, and the other one says first is false and second is true. So what can we do here exactly? Well, there are a few things that we can do. So first, let's move on to this problem. And here, if we write down this numerical value, it's going to be 7.12121212 like that. And now here what we can see is, yeah, we have a 9-digit sequence. Oh, sorry, it's 8 decimal digits and 2 whole number digits, in total 10 digit. So in the same way, we can write down 4 right here for the whole number section, and for the decimal section we can write more places like this. Okay, so now this is the part that we have right here. So now when we add both of these up, what we will be getting is 20.0343434434 and so on till infinity. So if I simplify this, it would be 0.034, where 34 is recurrent. So now this is the sum of the first arithmetic sequence that we have in decimal form. Now they say, according to the problem, that this is equals to 389 divided by 90. So let's see whether it's accurate. So first, let's divide 389 by 90. So then we can categorize this in a way such that it will be a whole number with a fraction, so it will be a mixed number. So 90 divided by 389 is said to be 4 and 29/90ths. So now we can obviously see that this is 4 and 29/90ths, right? But in the other hand, what we have here is a 20.034. So which means obviously these two cannot match. So which means this statement is false. So we can easily confirm the first statement as false and the third statement as well. But still we don't know whether, the second statement is true or false. So we'll have to test that out. So it says the cube root of 0.125 times the fifth root of 0.00032 to the power negative 2. And that whole thing divided by the fifth root of 0.00243 to the power negative 3 times 27 divided by 27 to the power 2/3 is equal to 3/80. So let's try to simplify each of these terms one by one. So first what we have is 0.125, right? So let's take just that root into a separate part just for this while. So then what we will have is the cube root of 0.125. So now if I express this in scientific notation, this will be this. This will be 1.25 times 10 to the power negative 1, which means one decimal is said to be going backwards. So we have this notation here for now. But for my simplicity, I'm going to simplify this a little bit more, this whole mess, and I'm going to turn this into 125 times 10 to the power negative 3, which is going to look like this. And you can multiply that out and you'll realize that it's still the same. So it will be the cube root of 10 to the power negative 3 times 125. So 10 to the power negative 3 can be expressed as 10 to the power 1 to the power 3 based on the exponent rule of a to the power mn is equals a to the power m all to the power n. Both of these are equal. Because of that reason, we can express this in that way, because negative 1 times 3 is obviously 10 to the power negative 3. So here now we can express 125 as 5 cubed, right? And now we have 2 cubed values here. So we can take the cube root out with both of these cubes. So the final value that we have here will be 10 to the power negative 1 times 5, thus giving us 0.5. Now this is just an expanded version of the explanation of the total solution. You can just find out the cube root of 125, which is obviously 5, and you have 3 decimals, and since we're finding the cube root, we had to understand that there should be only one decimal place in the cube root, and just like that we can determine it's 0.5. Still, it's no big deal. But I thought that I would like to explain this to you a little bit more deep, so I decided to explain it to you in this way. Okay, so just like that, we simplified one part of our fraction completely. And here the 0.125 cube root of 0.125 can go away from this whole math problem. And at the end, what we will have here is 0.5. Now we have a fifth root. So usually fifth roots are kind of rare in math problems, but now we have a fifth root in this math problem. So let's try to solve it. So when I'm solving this math problem, I'm using the same theory. And here, according to that, if my calculations are right, this should be 32 times 10 to the power negative 5. And in that way, we know the cube root of 32 is 2, because 2 to the power 5 is 32. And cube root of 10 to the power negative 5 is 10 to the power negative 1. And we can multiply these two together. And at the end, we will have 0.2. So now we can take that part out as well. And now at the end, what we will have remaining in that section is 0.2 and 0.5. Okay, so we kind of simplified the numerator really well. Now I can just easily multiply these two. And at the end, what we will be getting is 0.1. Because we have we have one decimal place in each of the values, so in total there are 2 decimal places in the answer. And when we multiply 5 times 2, the value is 10. And if we write 10, and decimal point is currently here, and if we move 2 decimal points backwards, it'll be 0.10, which is 0.1, because the zeros at the end of decimals mean nothing. So which means at the end, this whole value is equals to 0.1. Okay, so now what? Well, we can try to simplify the numerator as well. And what we have there is 0.00243 to the power negative 3. So 243, we can identify the fifth root easily, but if you by heart the fifth root equation, you obviously know the answer, but I will explain it to you. So 243, we can factor this out, and first we have 2 3's because this is divisible by 9. And when we take the value divisible by 9, what we get here is a 9 again, so which means we can multiply this like this. So now we have an 81, and we have, when we multiply that by 3, we have 243. So which means this is also 243. And now, when we simplify this into exponential form, what we get is 3 to the power 5, which means the fifth root of 243 is 3. Okay, now we know that we have 5 decimal places. So which means the cube root of that value should have 1 decimal value, right? So because of that, what we have to easily determine is that the final value is said to be 0.3 because 1 decimal place is required to be in the answer. And we know the fifth root of 243 is 3. So that is 0.3. But we still have a slight hiccup. And that is we still cannot complete the total simplification yet. We are not capable of doing that yet. And why is that? Well, if we take this value, and in case you didn't observe, there is a negative exponent right here, which makes the whole thing a little bit more complex. It's going to look like this. Because a to the power negative n is a to the power n divided by 1. 1 divided by a to the power n. So because of that exponent rule, we can simplify this whole problem. And we are supposed to be taking the power 5 root of this. And we can split the root to both parts, the numerator and the denominator. So this will be something like this. So this is 1, and this will be 0.3, but still there is a cubed, so this will be apparently 0.3 cubed, and 0.3 cubed is 3 cubed with 3 decimals, so it will be 0.027 over 1. Okay, so this is 0.027 over 1. Let's remember that in our mind, because still I don't think we can say that we're done with the problem. So let's remember that. 0.027 divided by 1. Okay. Now we can move on to this fractional exponent. 27 to the power 2/3. So when you have a fractional exponent like this, a to the power n divided by n. Here, this thing is equals to a to the power n, the nth